When I was reading through the Rust book for the first time, I remember thinking that having the terms reference and borrow was a bit redundant. Can you not just use one or the other? Do they not mean the same thing? In chapter 4.2 of the Rust book it says, "We call the action of creating a reference borrowing." So that's straightforward enough. If you're taking a reference, you're borrowing. And if you want to borrow, you have to take a reference. But do we really need two ways to say the same thing? Looking at references first, we see that they're built into the Rust language syntax. For some type T, you can create a reference to a value of that type. For example, a reference to a very big struct value, which saves you passing that large value between functions. You can just pass the small reference instead, which is a useful language feature. On the other hand, you won't find borrow terminology anywhere in the Rust language syntax. Ownership and borrowing are concepts relating to how references can be used safely. Every reference has an associated lifetime, and the borrow checker makes sure that lifetimes don't overlap in ways that might break your program. Imagine your neighbour borrows your lawnmower and says he'll return it by tomorrow lunchtime. Your other neighbour comes along and asks to borrow your lawnmower, so you tell her she can have it from tomorrow lunchtime. Tomorrow lunchtime could be said to be the end of the lifetime of the first borrow and the beginning of the lifetime of the second borrow. But this only works if everyone respects the lifetime. In the extreme case, if the first neighbour never returns your lawnmower, then they've stolen it, not borrowed it. Fortunately, that can't happen with references. The borrow checker won't allow it. This safety that you get with the borrow checker is such a key concept in Rust that you'll find borrow terminology used throughout the Rust documentation, and also in standard library type and trait names. For instance, the Rust reference describes closure capture modes in terms of borrows. And the standard library has this type and this trait. Reference safety through borrowing is so fundamental to Rust that borrow and reference have become synonymous. Here's an example from chapter 5.2 of the Rust book, where a function takes a reference as a parameter. But the book description says, rectangle whose type is an immutable borrow of a struct rectangle instance. However, there is often a reason to choose one form over the other. If a discussion relates to ownership and lifetimes, then borrow will likely be emphasized. In more technical discussions not involving ownership or lifetimes, for example syntax or memory structure, reference terminology is more likely. This excerpt from chapter 4.2 of the Rust book shows the use of both borrow and reference terms. It shows the code with compiler output, and the book description which says, "We also cannot have a mutable reference while we have an immutable one to the same value." The code is demonstrating the importance of the lifetimes of different types of references which are checked by the borrow checker, and so borrowing terminology is to be expected. But when describing the reason for the error at code level, reference terminology is used. One last thing before we finish. Have a look at this code. We see two examples of borrowing. The reference type iref borrows from I, and the reference type vSlice borrows from V. But the reference type sSlice doesn't appear to borrow, and there doesn't appear to be an owner. So you might think that this contradicts the Rust book's assertion that creating a reference is borrowing. But actually, as far as the borrow checker is concerned, this is a borrow. It's just that the lifetime of the reference is the special static lifetime, meaning that the reference data is static in memory and so valid for the entire duration of the program. The owner is also special, being the program itself rather than some variable created during program execution. The effect of this is that the sSlice reference will always be valid and can never fail borrow checker lifetime checks. So, to sum up, the term borrow is a powerful analogy for the safe use of references, and although a reference and a borrower are understood to be the same thing, each has its use in particular contexts. Thanks for watching, and please like and subscribe so that you don't miss out on the next video, which is on the subject of copy, clone and move.